Well, here's the thing with documentation. It's like sex. When it's good, it's great, but when it's not, it's better than nothing at all. Hey, I'm Dave. Welcome to my shop. I'm Dave Plummer, a retired operating systems engineer going back to the MS-DOS and Windows 95 days. And today's big project takes us back even further than that, all the way to the days of the Commodore PET. I've got a very rare and exotic piece of old Commodore hardware that's extremely cool, yet broken, and today we're gonna fix it, no matter what it takes. I'm talking about something that's so rare even the 8-bit guy doesn't have one and has never even shown one on his channel. In fact, I'm gonna throw down the gauntlet. I've got a real Commodore D9090 10 megabyte hard drive here, and it's a fascinating device. In fact, it's rare enough and interesting enough that I'm going to challenge the 8-bit guy to do a proper feature on the full history, sort of an adjunct to the floppy drive episode. I'll even donate $1,000 to the 501c3 charity of his choice if he does it in the next 90 days. And no, you can't have mine. Heck, I'll even make it easier and accept the smaller D9060 as an alternative, but it's got to be the real deal, a working Commodore unit that you can load to and save to using CBM-DOS. I know all too well how hard these are to find. In fact, since I lack the connections that someone like Biggie8 would have, I had to resort to creating an eBay search alert and waiting for one to come up. For about 12 years. And when it did come up, it was over in Germany and it was wired for their 220 volt electricity. That's how long it's been between decent D9090s appearing on eBay. But I'm sure David has enough friends in the hobby that he knows someone who has one. The one I found was listed on eBay as completely untested, incompatible with my power system, and at a price of more than $1,000. But as I said, it was the only one I'd even seen listed in a long time. There were many active bidders, and as the auction drew to a close, the price was approaching $2,000, which is way more than I thought I would ever spend for a Commodore hard drive. I know that much. But it was for the channel. It was for you guys, so just don't tell my wife. Or if you do, be sure to point out that they were more like $5,000 or $6,000 new, so this is really a pretty nice discount if you look at it that way. But why am I so passionate about the D9090 hard drive? Because when I was 15, it might as well have been a Ferrari Testarossa. They were seemingly as powerful and sexy and rare and exotic, and the odds of ever owning one seemed about equal. In fact, I'd probably been content to have a poster of either one of them on my bedroom wall at the time. Even my high school, which had a big lab with dozens of SP9000 Super Pets, they had to make do with an 8250 dual floppy unit. But as for the real deal Commodore D9060s and D9090s, they were like Sasquatch. Everyone had heard of it, but somehow no one had ever seen one. Ultimately, I only ever did see one myself. Oh, sorry, it almost slipped into my Sasquatch finding accent there. It belonged to a couple of fellows named Roe and Gary. They had it sitting next to their PDP 1140 that they had in their dining room. They needed it because they were writing a Commodore 64 terminal program whose claim to fame was the ability to do 2400 baud. The factory C64 could only achieve 1200, but they actually did it thanks to some excruciatingly calculated manual bit timings, which tells you most of what you need to know about Roe and Gary and their hardware tastes, which ran to the exotic, at least for 1982. You see, while the first computer I ever played with was a TRS-80 Model 1, the first computer I ever owned was a Commodore 64, thanks to my mom and dad back when I was 14. We also had those Super Pets at my high school, so most of my formative computer experience really was on the Microsoft Basics and 6502 assembly for the Commodore machines. For a while in the 1980s, I dropped out of high school and worked for a software house that contracted for game publishers like Electronic Arts, Epix, and Accolade. I jumped in my 1969 Pontiac for the 35-hour drive eastbound from Regina out to the suburbs of Ottawa. I joined the programmers and artists behind games like Ace of Aces, Dam Busters, BC's Quest for Tires, Fight Night, and other old classics. I was personally busy working on their cycling game called Tour de Force. Everything was pure 6502 assembly, and I used a very cool development system by the name of TSDS for Total Software Development System. It was written by an evil super genius named Kevin Pickel. Well, I've only ever met Kevin once, so I don't really know if he's evil, so we'll just say super genius. But in addition to significantly improving the C64 dev environment with a DOS wedge and many new commands, it used a special cable to connect the C64 to the Amiga, such that a folder on the Amiga appeared as a drive on the C64. And it loaded in full parallel as fast as the C64 could take it. It was basically sipping from the fire hose of data available from the Amiga, and it was enormously faster than the original floppy setup. Taken as a whole, this meant you could assemble your code using a 6502 cross-assembler on the 68,000 based Amiga, which was also super fast compared to doing it on a C64. It would then be dropped right into the output folder, which appeared as a drive on the C64, and it loaded at speeds an order of magnitude faster than the original setup. It was so much faster than assembling natively on the C64. But what does all this have to do with a PET and the D9090 hard drive? Well, one day when I was working there, back in 1987, a few of us programmers went for lunch, and on our way back, we stopped in a computer recycling store where they just still happened to sell Commodore PETs. Now imagine a computer recycling store in 1987. Everything was then about 5 to 10 years old, which makes the place an absolute museum by today's standards, but back then it was just full of the classic 8-bit hardware that they were basically having trouble giving away. They had PETs galore, turned in mostly by schools that had moved on to PCs, so I decided to grab one for nostalgic purposes. But the 32K PETs were already over $100 each, but I scored a minty 4K PET for just $20. My friend John was a hardware guru that naturally kept the RAM chips I would need in stock at home, so he was going to quickly expand it to 32K for me. Quite a savings, or so I thought. All he would have to do is drop in simply a new row of RAM chips into the empty sockets on the motherboard and turn the machine on. Well, usually anyway. That's how it's supposed to work. But you see, Commodore did not want its users doing precisely what I was about to do, expand the factory RAM on my own. To prevent it, they had literally drilled holes through the motherboard in each of the empty RAM locations. I imagine they charged a big premium for the memory when you bought a PET already populated with 32K, so they didn't want you just buying the cheaper PET and then expanding it yourself with simple over-the-counter parts as I had planned to do. The PCB paths were all severed, and there was no way for a regular person to simply expand the RAM of a 4K PET on their own once they got it home. Fortunately, my friend John was anything but a regular person. He promptly broke out his soldering iron, a wire wrapping tool, and some of the finest blue thread-like wire that I'd ever seen. He then proceeded to painstakingly restore each and every one of the circuit paths that Commodore had destroyed. He did it by wire wrapping a new wire jumper from its source pin to the destination pin and replacing every single missing original trace. I don't remember how many wires he had to do, but there are 8 chips with about 18 traces each, and if half on average were missing, that's over 70 manual hookups. From all appearances, that was probably pretty close because the back of that PCB looked like a complete rat's nest, and I figured the chance of it actually working were pretty slim. When he was finished, we flipped the switch, and somewhat to my happy surprise, we were greeted with the banner: Commodore Basic 2.0, 31743 bytes free. It then proceeded to work perfectly for the next 30 years or so. It followed me from being a teenager in Ottawa back to Regina and ultimately on to Seattle. However, that PET is currently in the shop for a keyboard issue. So you see, PETs are notorious for keyboard issues of both the physical and the logical kind. You might find this surprising given my middling hardware chops, but I actually used to be a real-deal Commodore repair tech. At least to the extent that I was the Commodore repair tech at a computer dealer back when I was in high school in the 80s. A good friend had secured the interview for me, and for some reason, likely my willingness to work pretty cheaply perhaps, the company hired me. Every day after school, I would head on in and face the onslaught of newly dead C64s and VIC-20s and so on. A solid half of that was made up of 1541 disk drives that were either overheating or out of alignment or both. I aligned a lot of 1541 floppy drives with the trusty reference disk and an oscilloscope, that's for sure. I came to be able to spot most of the common problems and knew most of the solutions by heart. The C64s were quite prone to bad pet-ieee chips, which would interfere with the keyboard or disk drive. If the sound was bad, it was likely the SID chip. Bad video meant the VIC chip. But if naively swapping components for major functions didn't work, my solution was to set up a working machine next to the failed one, use 2 oscilloscope probes, and then just work backwards down whatever circuit it was to find where it started to differ between the 2 machines. It might not have been really elegant, but hey, I was 16 years old and it got me by. I slowly learned as I went, but as things got busier and busier, they ultimately hired an additional technician, and the new guy was full-time. Believe it or not, it was Gary of the PDP-11 fame, the guy who owned the only other D9090 that I've ever seen. Small world. Well, small city, actually. But he was a hardware rock star because he knew all about diodes and resistors and even transistors, and so pretty soon he took over the whole deal, and rightly so. Back in the near-present time, however, my own pet stymied me. I went through the physical keyboard over and over to no avail. I swapped the 2 pet-ieee chips with each other, and there was no change, which told me they were likely not the problem. With no good machine on hand to compare to, as I used to, I was forced to apply a little more deductive reasoning. Starting with the scope, I started chasing the signal that resulted from pressing a non-working key like the E key. I followed the signal as far as I could, and it looked fine to me. At some point, it went through a chip that did a lookup or a decode of some kind, and what came out the other side wasn't recognizable, but I wasn't entirely sure what it was trying to do, so I couldn't tell if it was right or wrong. So I was stuck. I sent the motherboard back to John in Canada, whom I hadn't seen in some 25 years. Long story short, he was unable to fix it, but then it took me a year of nagging him to get the board back. Once I did, I then found a nice fellow at Microsoft with a lot of Commodore hardware knowledge, and he graciously agreed to look at it for me. It had quite a number of smaller problems, like bad caps as well as a blown IC somewhere, I think a 7545, that was interfering with the keyboard decode logic. You see, the thing is, pets, they don't live forever. So even though I love my pets, sometimes they die and you need to get a new one. Well, here's how it works. I have one pet in the house for a long time until that pet dies. Then I take that pet and I take it down to the pet cemetery and I get all the parts necessary to make a good living pet. And I bring those parts home and I assemble them into a pet, and when the pet is working, I live with that pet for many years until that pet fails and dies, and then I take that pet down to the pet cemetery and I get the parts for the next pet, and the cycle repeats. It's the circle of life. It took a few weeks for the drive to arrive all the way from Germany. I knew up front that I wouldn't even be able to plug it in because it was a German unit and therefore it expected 220 volt power. In order to make the conversion to 120 volt US power, I enlisted the help of an old friend named Kevin from Microsoft. Kevin was actually the guy who walked me around from building to building during my very first job interview at Microsoft in 1993. He's deep into the electronics and robotics scene, and so I was confident that he'd know how to address the problem. He brought by basically the solution to my shop, a completely new self-contained power supply. What made it unique, and I didn't even know that these existed, is that it produces both 5 and 12 volts. How handy. We would simply pull out the bulky original transformer and power supply board and replace everything with a simple box that solved all the power needs at once in a domestically compatible fashion. Because now, of course, it could be powered off 120 volt wall current. Now, if for some reason I wanted to restore it back to original, I have the parts down at the pet cemetery and they can just be swapped back in, but then it would be 220 volts again. We carefully figured out which wires were 5 volt and which ones were 12 volt, and we wired it all up. I nervously flipped the power switch. There was a moment's hesitation before the drive began to spin up, but spin up it did. It built up speed until it got to the requisite 3600 RPM or so, but then something strange happened. It slowed down a bit, like there was some kind of drag on the disc, and then it blew up the power supply. And then it tripped the GFCI breaker in the outlet. Something was clearly unhappy. Long story short, that physical hard drive would never spin up again. I even cracked the hermetic seal and opened it up to ensure it wasn't a case of stiction where the heads settle into lubricants on the platter and get stuck after a time, or something related to that, but no matter what we tried, as soon as it was connected to a 12 volt supply, it was basically a dead short across the power pins. It would demand and accept all the 12 volt current it could get, and that meant either a fuse would pop or the entire power supply would smoke. And strangely, it kept on popping the breaker on the outlet, as I mentioned as well. With the power supply now toast, we tried to mock it up using 2 benchtop power supplies, one set to 5 volts and the other set to 12 volts. We tried both with and without sharing the ground, but it proved fruitless. It would pop the breaker every time we tried to power up the drive. That much did not and still does not make sense to me. I was under the impression that a GFCI outlet essentially detected AC current leakage, like if the current takes a shortcut back to the power plant via your soggy tennis shoes, it would trip in response. But if that's the case, where is this current leaking to? Particularly on the AC side, what could happen inside a device like a hard drive that would cause the AC breaker on the other side of the DC power supply to trip? I mean, repeatedly too, so if you have a theory, please let me know in the comments, as I still don't understand precisely what was or what could have been happening here. I even replaced the outlet itself for good measure, but I never did solve the mystery of why it was tripping originally. The big Commodore drives originally shipped with one of 2 mechanical disks. The Tandon TM603S for a formatted capacity of 7.5 megabytes, or the TM602S with a formatted capacity of 5 megs. Yet when I looked at my drive, it was a Tandon TM503. So not only was the drive not the original drive for the unit, it wasn't even the right model number. Now here's where it helps if you know a little bit about old MFM hard drives, so let's take a brief little side trip down memory lane to talk about how they worked. Fundamentally, there were 2 numbers you had to worry about back then. The number of cylinders that the drive had and the number of heads. Multiplying the 2 gave you the number of tracks on the drive. That track would then be broken up into sectors and so on, but you generally didn't have to worry about that yourself. The TM603S that should have been original to this unit, now long gone, would have had 153 cylinders on each of 3 platters. Each platter has a head on each side for a total of 6 heads. They have 32 sectors per track, and each sector is 256 bytes. And if you multiply all that out, sure enough, you get 7.52 juicy megabytes of storage for your ASCII art porn or whatever it was that people stored on hard drives back in the 1980s. These days, hard drives are intelligent and have their own controllers built right in, but back in the day, this style of drive used an interface named the ST506 in honor of the first Seagate drive in that series. It's the 2 cable with the fat cable and the skinny cable and then power separate, so it's actually a 3 cable setup. All the drives in that series were rather dumb. All they could do is be told to jump to a particular cylinder and then to read or write from one of the heads. The number of heads and cylinders had to be either entered manually and saved somewhere, or in the case of the Commodore setup, hard-coded in ROM. There were only two geometries used by Commodore, that 5 meg and 7.5 meg, and a jumper on the main board determined which one was to be used. Printed on the label of every hard drive back then was also a defect list. The manufacturer would test the drive at the factory and then provide a list of known bad tracks on the drive. Each track would be identified by cylinder and head number. The D9090 doesn't seem to care. It will brute force a format right over them and then just stop if it sees too many errors. There's no mechanism for entering bad sectors that would enable it to work around the defects in a drive as far as I can tell. Because of this rudimentary cylinder and head control scheme, you could actually just use any drive that had a geometry at least as big or bigger than the drive you were replacing. So while my original drive was supposed to have 153 cylinders, I could in theory use any replacement drive with at least 153 cylinders. Any extra would just go unused because the controller would never even know they existed and would simply never reference them. And it's the same for the number of heads. As long as you have the same or better number, it all just works. Remember, the drive doesn't even know how many cylinders it has. It's printed on the label if you're lucky, but other than maybe knowing the landing track zone for parking the heads, the drives seem to know very little about themselves. It's a good thing, too, as finding the original TM603S drive is also nearly impossible, and if you do, they are very expensive on their own, because I think they're actually popular with the PDP-8 and PDP-11 communities. But I didn't need an original drive, I just needed something with compatible geometry, so I jumped on eBay to see what I could find. The first thing I found was that prices varied wildly, from like $20 and $50 up to like crazy prices. The second thing I discovered was that all of these old drives on eBay are sold without a guarantee and are generally of unknown working status. Sometimes the seller will tell you if they power up or not, but relatively few people have the old PCs around with ST506 controllers in order to test a drive like this, so you're taking a gamble when you buy an old drive off eBay like that. It turned out to be a gamble that I would make and lose over and over and over again, but more on that later. To improve my odds, I ordered a drive that was listed as NOS, or New Old Stock, meaning that it was still new in the box and unused these 40-some years later. I figured it was no guarantee, but it was the best chance I had of getting a working drive. So I ordered the ST251 drive, and when it arrived, I went about wiring it up to the power supply and so on to get it all working. But to my great disappointment, when I did power it all up, now I had a mainboard fault on the D9090 itself. The power LED would blink 5 times at power on with some trouble code. Not only was the original drive itself bad, but so were the electronics. It appears I had purchased a rather expensive and very broken German paperweight. I couldn't even make it far enough to check if the new drive I had just purchased was working. So with no other real option, I set out to see if I could fix the circuit board. There are two main circuit boards in the D9090, besides the power supply. There's a Commodore board up top that communicates with the host computer over the IEEE 488 interface, and a SASE disk controller board. SASE, which stood for Shugart Associates System Interface, say that one 10 times fast, is a very early version of what would become SCSI, the Small Computer Systems Interface. The hard drive talks to the SASE board, which talks to the Commodore board, which in turn talks to the host computer. After a little searching online, I found the old original Commodore technical manual for the D9090. Right there on page 23 was my answer. The 6810 static RAM was bad, at least according to the self-test and the 5 blinks. I jumped back on eBay and, good luck, I found a pair of 6810s and so I ordered them. About a week later they arrived and I had a look at the chip on my board. It was 24 pins and it was not socketed. Having manually desoldered dozens if not hundreds of the big 40-pin ICs in the 64 in my days as a tech, one of the indulgences I've allowed myself over the years is a Hakko desoldering vacuum gun. You put it over the pin, let it heat up for a second, and then pull the trigger. The built-in vacuum sucks the liquid solder from around the pin and makes life immeasurably simpler. Trust me, if you do any amount of through-hole pin desoldering, treat yourself to one. I put a link in the video description. The vacuum tool made quick work of all 24 pins, and after breaking them free a little bit each to be sure, I popped the original chip out of the board and resoldered one of the new 6810s in its place. I had very little hope, to be honest. I wasn't sure how likely it was that the LED code was even accurate, and that it was the only problem that this particular board had, or that I had the ability to properly replace a fairly statically sensitive chip like the static RAM. Nonetheless, I hoped for the best and I flipped the power switch. The LEDs danced between red and green for a second during the boot and then settled on precisely what I was hoping for. Dual greens, good to go. I connected the drive to the PET and typed in a rudimentary little program to read the disk I/O status out of the controller and then print it on the screen. I was surprised I could remember basically everything I needed, but after fixing a few syntax errors, I was greeted with exactly the message I was hoping for. 73 CBM DOS v300. My chip repair was a success and all was well on the electronic side now. So I proceeded to connect to the ST251 drive that I had acquired up to the controller and the power supply, and when I was done, it all spun up perfectly, no immediate errors. The sound of an old MFM drive spinning up is actually pretty cool and it's worth a listen, so I won't talk over top of it for a few seconds. Let's have a listen. I loaded up a CBM DOS wedge, which allows you to communicate more easily with the drive. As you may be aware, Commodore drives are somewhat unique in that the drive has its own processor, memory, and so on. They're actually fully fledged computers in their own right, but they operate headless with no display. The DOS wedge lets your computer, like the 64 or PET, talk directly to the controller in the drive and send commands to it and read its status back out and so on. Because out of the box at least, a basic 2 machine has no real mechanism for working with a drive unless you write a lot of fairly ugly input and output code. Using the wedge, I kicked off a low-level format. The Commodore controller takes forever to format a drive, as in several hours for a mere 7.5 megabytes. It does something like 6 passes with various test patterns to ensure the drive is perfect, and perfection takes time apparently. But I didn't have to wait very long. I could hear the stepping around initially, but once it settled in and started doing the actual sector formatting, it started to blink 11 times instead. That's not even a standard error code for these drives. 1 through 10 are the error codes, but it's something that can occur apparently during a low-level format if too many bad sectors are encountered in a track. I have no idea what it determines to be too many, but it's unrecoverable and the drive would simply not proceed any further with the format. I even tried it upside down and right side up for good measure since the drives are reportedly sensitive to their orientation, but it would still error out every time. Somewhat defeated at still facing problems after fixing both the electronics and the hard drive, I felt I just couldn't give up at this point, so I ordered a second ST251 drive. When it arrived and did the same thing, 11 blinks, I was surprised. But when the third drive that I purchased did the same thing, I started to seriously doubt whether I was really having a run of very bad luck, or if perhaps there was some fundamental incompatibility between the D9090 controller and these ST251 drives. One of the drives wouldn't allow me to low-level format at all, however, so I suspected that the onboard electronics were bad. To eliminate the ST251 itself from the equation, I next ordered a Micropolis unit that had 6 heads and more than enough cylinders. It sounded cool while spinning up, but it immediately blinked out an error code that I had to translate to binary and look up in one of their long tables. When I did, it indicated that it was unable to stabilize its rotation speed at 3600 RPM. This happened long before it could even attempt a low-level format, so in the end I didn't learn much from the Micropolis drive. At that point, I was 4 drives in, plus the original it came with, and I still wasn't 100% certain that I really had that many bad drives, or if I was just doing something wrong or working with some incorrect assumption. I decided to take it in another direction. I'd replace the mechanical hard drive unit with a self-contained box that would pretend to be an MFM drive while really storing the data on an SD card. An MFM emulator of sorts. And then I could make it claim to have exactly the correct geometry I wanted with no errors of any kind. Now, I had no idea if such a thing even existed, but a quick Google search turned up 2 different solutions. Both apparently came not out of the PC or retro markets, but actually from people working with the old digital mini computers like the PDP-8, which apparently also used the MFM drives with the SD506 interface, or so I can only assume. Out of their needs arose a solution to my own problem. At the same time, I also ordered a 6th hard drive off eBay, because you never know. Maybe they really were all bad and I'd get lucky eventually. Fast forward a couple of weeks and the MFM emulator arrived. An impressive piece of hardware to be sure, but the documentation. Well, here's the thing with documentation. It's like sex. When it's good, it's great, but when it's not, it's better than nothing at all. I mean, all it told me to do was to connect it via Engadget USB support, build the required software somehow, and install it somewhere. And since I didn't have a Linux desktop handy and WSL doesn't support serial ports properly, I was forced to use the Windows or Mac. Unfortunately, both of those operating systems seem to have abandoned the RN disk drivers needed to do Ethernet over USB ports in their recent versions, so I couldn't connect to it without turning off driver signing and all that, which I didn't even want to do on my main good dev machine. Sadly, it never occurred to me in all of this that I probably could have just used a Raspberry Pi as if it were a Linux desktop, complete with its USB ports. Duh. I bet it probably would have worked too. I was working on setting up Windows 7 in a Hyper-V VM since it still had the drivers I would need to mount it over USB. While I was working on that, however, I realized that if the emulator is basically a Pi, I could likely add an Ethernet adapter to it somehow. Taking a shot at it, I plugged the USB to Ethernet adapter into the emulator and I waited about 30 seconds, and sure enough, a link light appeared at the switch. But it never requested an IP, so I was kind of stuck again. The one thing the documentation did say was that the USB ports had weak sauce for power. So on a hunch, I ordered a powered hub off Amazon, plugged the Ethernet adapter into the powered hub, and then plugged the hub into the emulator. It was sort of a desperation measure, sort of a last resort. And then, boom, instant IP address, 192.168.1.64. About 5 seconds after that, I was in like Flynn, connected as root over SSH with a blank password. The emulator board that I'm using is called the Decromancer. Once I solved the whole getting connected problem, it was smooth sailing, and I highly recommend the Decromancer board in place of any MFM drive if you have even the modest Linux console skills needed to configure and deploy it. And just to be clear, I paid for my own board, and this is not sponsored in any way. The board vendor helped me all through the MFM config and setup, and with nervous anticipation, I physically installed the emulator in place of the hard drive and I flipped on the power switch. Dual greens, all good so far. A status query came back okay, but the controller hadn't been asked to talk to the drive yet, so it didn't really mean much. I went to the PET and I issued the low-level format command. Suddenly, my SSH Windows console was alive with logging information. I could see as it moved the heads to each cylinder and then requested a read or write or whatever operation it was doing from each individual head. As mentioned, a low-level format on a D9090 takes hours. It does a super thorough scrubbing of the disk with something like 6 different bit patterns in sequence, or so I guessed from watching the log file scroll by as the format progressed. Thinking about the math a little bit, the Commodore IEEE 480 bus, at least in testing, seems to transfer only at 1500 bytes per second. The 7.5 megabytes of drive could be read or written once every 5,000 seconds, which is 83 minutes. So it's a good thing the controller is on board and directly connected to the drive, because if the format had to be run over the bus cable, it would take a solid day or more for all of those passes, I'm sure. But only a few hours later, I came back to the shop and one of the sweetest status messages I've seen in a long time. 0, OK, 00, all golden. 21,962 blocks free. A quick directory command confirmed the drive was indeed responding. There's no way, at least in the early versions of BASIC, to copy a file from one drive to another. So to test the drive, I loaded a BASIC program I'd written from one drive and then tried to save it on the D9090. Success. I next loaded it back and everything still worked. All tests were go, and I was a proud owner of one fully functional and truly enormous, at least for its day, flat file system. Good luck finding anything on a flat file list of 1,000 files, though. Soon after, the next ST251 drive that I'd ordered actually showed up from eBay, and believe it or not, in this one I had finally found a candidate that would survive the low-level format. I keep the physical drive in there for the cool sound, though. An even bigger reason, though, is that since it's just running Linux, I installed and configured a Wi-Fi adapter on the emulator board to bring the D9090 up on the web. And so, just like my TRS-80, you can access it worldwide and read and write files to my pet from anywhere. The only problem is that the TRS-80 is limited to 4 simultaneous visitors and crashes on the 5th, and neither has any security whatsoever. So while I don't advertise them publicly, they're out there. Both of them probably contenders for the world's smallest capacity FTP sites. If you're on the Discord chat, keep your eyes open for when I share the IP and port, and we can party on them like it's 1989. I'm not selling anything, and I don't have any Patreons. I'm just in this for the subs and likes. So if you enjoy it when I document these little retro computing journeys, I'd be honored if you consider subscribing to my channel. If you're already a subscriber, drop the video a like or leave a comment to let me know that you're out there and that you enjoyed it. I try to read the comments each and every day, and I usually drop by the Discord server as linked in the video description. If you're a subscriber, stop on by to chat with myself and the other subscribers. With me. And now, off to satisfy my collector instinct by amassing sheer megabytes, yes, megabytes, of Commodore pet games and other downloads that I will never use in any way. But I gotta fill that drive with something. In the meantime and in between time, I hope to see you next time, right here in Dave's Garage. Subscribe. Are you subscribed yet?